want to do? First thing that we want to do is we want to say, okay, we're looking at calculating an inbreeding coefficient for individual I, right? How many common ancestors, how many loops are there? Let's identify the loops for I. There's two different loops, right? Here's one loop, loop 1, and then loop 2. So instead of, let's just take it step by step. Let's calculate here, loop 1. Let's just calculate the component, the part of the inbreeding coefficient that loop 1 is going to contribute. We see here, what is n in loop 1? 3, right? So n equals 3, so the component of the inbreeding coefficient is 1/2 raised to the third, which equals what? 1/8. Okay, that's loop 1. All right, here was labeled loop 1. So now let's look at loop 2. Here, 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 and here. Again, it has 3 individuals, but what else do we notice? We notice that this individual, this common ancestor, is also the product of inbreeding, right? And so we have to use this new formula, which is going to say, okay, that equals F, which is just the regular, right, inbreeding coefficient, times what? 1 plus the inbreeding coefficient of the common ancestor. Okay, so let's first look at the inbreeding coefficient of the common ancestor. We'll just call it F of, we'll just say CA. Inbreeding coefficient of F of CA, right, of this common ancestor. We'll actually label it common ancestor here so we know who we're talking about. How many individuals are in that loop? It's just a single loop with how many individuals? 1, 2, 3. So 1/2 to the third is equal to 1/8, right? So now we have the F of C that we can plug into here. So 1 plus the F of C is 1/8, right? What is the normal sort of inbreeding coefficient or component of the inbreeding coefficient for loop 2? 1, 2, 3. That equals what? 1/8, right? So now we times those out. 9/8, just like the last one we did, equals, or 9/8 times 1/8 equals what? 9/64, right? So that's the component of loop 2. The component of loop 1 is 1/8, right? So we go loop 1 plus loop 2 equals 1/8, but let's get it, into a common form. We'll call it 8/64 plus 9/64 equals 17/64. Okay, so that's how we would do it. So you have to, the one issue that students sometimes have is that they don't look at the contribution of each part of the loops, each individual loop. One loop can be the product of a common ancestor mating, but that doesn't necessarily mean that the other loop